All right. Hey, everybody. Welcome back. So today we're going to be doing GLSL Advanced Pops 2, the final course in our Introduction to GLSL for Pops and TouchDesigner. Finally, we're going to be continuing our example from the last time, which was real-time Voronoi tiling. And we're going to be focusing specifically on outputting additional buffers and writing to those buffers. So like I said, I'm picking up where I left off, so I'm just going to jump right into things. No further ado. Catch me on my Patreon, and let's finish off this course. Okay, so here we are. Like I said, exactly where we left off from the last lesson. Here, I've just put back what we're going to be doing in this lesson, which is writing these additional output buffers for the yellow lines and the cracks. Now, I'm going to, again, do this a little bit differently. We are going to talk through some of the code because it is important, but we're also going to talk through, very importantly, some of the setup. So before we get into this code, we're going to do a quick example to go through the multiple outputs. GLSL Advanced. Okay. Let's give it a point generator. Put that in. Okay. Now, what I'm interested in is not this point generator itself, but rather how to set up the extra outputs. Now, one easy thing to do, or actually, it's the best way to say this. The thing to know is that to set up an extra output, you need to define it using a different pop that will set the number of units of geometry it has, as well as its attributes. So, for example, if I have a single point, and let's say I give it an attribute count, that's like an integer, I can name an extra output count. I can give it this pop, and I can give it access to the count attribute. And this will allow me to do something like td point underscore count underscore count zero equals one. Let's see what that does. And then we can do a pop 2. Okay, that was stupid. So what I need is a GLSL select, duh. And then I'll take that name, that output name count. Okay, there we go. So we're not actually editing this input. This is more like a template to declare the GPU memory allocation. And then we can see here, yeah. Changes to our code are updating the changes to this output. And so, for example, I don't know, we could have another output that has like another attribute or something like that. You also use this sometimes for like atomic counters. It can be pretty helpful. So generally, this is the high level setup. And now, for example, what if I wanted to try and do element 2 though? So because we see that because I'm now setting element 2, but element 2 doesn't exist, and so we're not seeing that, right? But if I were to add more elements, so now we have 8 points, and there's 8 points in my output, and we'll see that the count attribute just for element 2 is set to 1. And so now I think hopefully it's a little bit more clear kind of how this extra output declaration is set up. we have a template attribute, or sorry, a template pop that sets the dimension and all of our attributes. Then we have a GLSL advanced pop that actually performs some logic. And then we have a GLSL select pop that will select the updated output. So, with all of that said, how do we apply it to our existing shader? Advanced output example. How do we apply it to our shader? So what I want to do is output lines. Now I'm going to do this with a little bit of a hack, let's say. And what I'm going to do is define a line for every primitive that I have. So I have a line right here. My line, just 2 points, 1 division. So each of my line has 2 points, right? Then I have an attribute. I'm giving it a color. Now here's the important thing. I'm taking a copy and I'm copying that line for every one of my primitives. I'm not doing anything. They're all overlapping. But now I have a bunch of points because I'm copying that line over every one of my input primitives. Again, this is a hack, and it's basically set up to allow me to be able to reposition a line per primitive, which is what we're doing in our shader. So now that we have all of those lines set up, we have this additional output in our GLSL advanced called cracks out. Again, I'm using this null2 as the template pop, which declares how many pieces of geometry there is in that output. And then I define here my point attributes that I'm interested in reading to and writing to. Now, the only real change that I had to make in my edge crack was adding this Q. And the Q is basically going to be our lines. So it'll make more sense if I come down here. So this is where we left off last time, right? This is part 2. So the first thing we do is define a little array for the cracks point. And here is where our Q comes in. So remember, we defined Q as an in-out vec3. And so we're setting Q in our edge crack function based on the results of the calculation, right? And so in the edge crack function up here, we have our relative distance function, right? That's getting checked based on the input points and the two based on the input points and the 2 sites that we're looking at, or the 2 regions, really. Where are we at here? So this section, essentially, sorry, I'm just checking my notes. This section is saying we're solving for when t equals 0, basically, to determine where this Q should be. And Q is going to actually be a vec3 point that we're going to use to reposition our lines. Okay? So the reason that we do this is to basically find a 3D point along the edge where the boundary passes. And we can use this 3D point along the edge to set our crack points. Now, our crack count, we're adding each time we have a point that's on an edge. And so then our final step is to use that crack count to determine whether or not we're going to reposition a line. Now, here we're saying, okay, if our crack count is 2 or 3, then what we're going to do is literally write to our cracks out output position attribute at the index of line point 0. Okay, what's line point 0? Good question. I forgot about this. Line point 0, I'm actually just setting up line point 0 using our prim index and multiplying by 2 because each line has 2 points. Each primitive has a line, and each line has 2 points. And then we are initially moving all of the lines super far away so that they're not rendered at all unless we decide that we want to render them. And then down here, because we already know what the points 1 and 2 are from above, we can just set the position of those points equal to the points on the crack that we calculate in our edge crack pass. And then finally, we can color the line if we want to. I'm not doing that here. Well, I am, but I'm using a material, so it's getting overridden. And then the same thing, if we have 3 cracks instead of 2, it essentially just means that it is a junction point, and so we perform the exact same thing, but we're positioning it at the center instead, so it's like a nice weighted average. And then again, TD point, OTD point, underscore cracks out underscore P means the position attribute of the cracks out output points. And then I simply use a GLSL select to select that cracks out output, as I said. And we are rendering it. So I could turn this off the render easily. I could also turn this off, so we're rendering just the cracks. And that is GLSL Voronoi tiling in the POPs GLSL Advanced, including outputting extra buffers for the lines. I acknowledge that this might be a little bit hard to follow and a little bit confusing, so there's going to be more tutorials demystifying the usage of the GLSL Advanced, but again, for a number of reasons, I want to close the book on this example, close the book on this course, and wish everybody happy holidays also. I think it's kind of great going into the holidays with some time, so I hope that you are able to get some free time, do some fun creative stuff, and keep learning. Till next time, happy creating.